In this video, I will show you how to use formulas in Excel. Formulas are very useful in Excel and you can do a lot of things. And I'm going to do it here using the example of calculating Z-scores. So here I have copied some numbers from our data set to a fresh sheet in Excel. And if I click on this number here, you will see it appearing up here. The contents of this cell are in here. And this cell is also highlighting its coordinates. So it's column A and row 2. If I click here, that's column A, row 3. So the first thing you need to know is that I can add a formula to any cell by starting with the equal sign. So everything that starts with the equal sign is a formula. So I can now type equals A2 plus A3. And this instructs Excel to enter the sum of these two numbers into this cell. So I'm pressing enter and you see 98, which is the sum of 47 and 51. Okay, we don't really need this number, so I'm going to click here and press delete so that it's deleted. An easier way to add or to include cells in any formula is by clicking on them. So I didn't have to type A2 and A3. I could, let's enter the equal sign. I can click on A2 and it's automatically entered here. Then I type plus, I click on A3 and I have the same formula and the same result. And I'm going to delete it again. So first of all, we're going to need to compute the mean of these numbers, which means we need their sum. So what we could do is enter equals and then this plus this plus and so on. This takes a long time. And if we had hundreds of numbers, it would be very tiring. Indeed, it wouldn't be worth the effort of using formulas. There's actually a much better way, and that's through Excel functions. So Excel has a sum function. I can type sum, type the 3 letters, and open parentheses. And now I can tell Excel which numbers I want to sum. And I can give Excel the whole range by holding the click. So I click and hold clicked and pull down. So I enter a whole range. And now Excel displays A2. The colon here means all the way up to A15. And you can see the whole range selected. So closing parentheses, I'm typing the parentheses to close. Remember, it's very important. Every opened parenthesis must close. Otherwise, it's an error and you're not going to get a result. So the sum of the range from A2 to A15, I'm pressing enter, and that's the sum. Let me delete this and show you another way that you can select a range of numbers that are contiguous, like this one. So I'm typing equals sum, open parenthesis. I click on the first number, not holding the click, and then going onto this little square at the bottom right of this cell, and I can pull it down by holding the click on it, which is the same thing as selecting the range before. So now all I have to do is close the parenthesis and press enter. Okay, so I have the sum of all the numbers. The next thing I need to compute the mean is how many they are. And Excel has a function for it. I'm typing equals and then the word count, which will literally count them. Open parenthesis and select the same range by click hold all the way down. Close parenthesis, enter. That's how many they are. And the mean is equal to this divided by this. And that's our mean. Actually, I could have done it in an easier way because Excel gives me a function for it. So I could have typed equals average. Unfortunately, Excel uses the word average for the mean instead of mean. Open parenthesis, select the range, close parenthesis, and of course I get the same result. So this is our mean, and this is our mean too. This is our count, and this is our sum. I'm just typing here, no equal signs, just labels for us to know what is there. Okay, now I need the difference of each measurement from the mean. So what's the difference of this from the mean? Start with an equal sign, and I click on this minus the mean. So I'm going to click on the mean. Enter. That's the difference. It's minus 10. So 47 is 10 below 57. That sounds right. And I can do equal this minus this, and so on. That's going to take a while. So you probably have guessed I'm not going to do it like that. There's an easier way. So I'm going to go back and delete this one. One way to repeat a formula is to drag it down. So if I click on this little square here and drag it down, it repeats the formula by dragging the values. So I started with A2 minus A19, and then Excel automatically, when I dragged it down, it turned 2 to 3 and 19 to 20. So instead of subtracting this from this, if you go one down, it subtracts this from this. And if you go further down, we subtract this from this. You see a problem here? The problem is that using these numbers, so going down on this range was appropriate. So Excel was right to turn A2 to A3 to A4 to A5 to A6. This is all correct. But it shouldn't have turned A19 to A20, then 21, then 22, and so on, because all of these need to be subtracted from the same cell, the mean. We want this 19 to stay 19 and not to be increased when we pull down the range. So what can we do? These are all wrong because they don't subtract the mean. We go back here and say, I want 19 to be fixed. And using a dollar sign in Excel fixes this in the formula so that it will not change. I'm pressing enter. And now pulling down the range looks a little better. If you look at each of these, you see that what is on the left of the expression changes. So it's A10, 11, 12, but the second term is always A19 because the dollar has prevented the 19 from increasing. So these are actually the differences that we want. So it's our values minus the mean. And these are our values. Let's separate a header row so we know what we have. So these are the differences from the mean. What else do we need to do to calculate a standard deviation? Well, we need all these differences to be multiplied by themselves, right? So what we want to create here is these differences squared. And how we do that equals this times itself. So the asterisk is for the multiplication, and I click on the same cell again. So it's this number by itself, enter. So if I pull down this range, then every number will be multiplied by itself. Or instead of pulling down, I can just double click on this little square here, which is the same as pulling to the end of the adjacent range, because there are contiguous numbers here. So these are these numbers multiplied by themselves. So now we have all the squared differences. What do we need to do with the square differences to calculate the standard deviation? We need to add them up. So I'm going down here and typing equals sum, open parenthesis, and select the whole range by clicking and dragging and close the parenthesis, enter, and that's the sum of the square differences. And what do I need to divide this by? Not the count, but the count minus 1. So what we can do is calculate this minus 1. So now I can divide this by this. And I need one more thing to get the standard deviation, is I need the square root. So what is the square root? Is there is a function in Excel that's called sqrt, open parenthesis, close parenthesis, enter. This is our standard deviation. And actually there is a function I could have used. It's called stdev. Which of course produces the same number. So this is my n minus 1, and this is my standard deviation. And this here is the variance. This is also the standard deviation. Okay, now we're getting somewhere. What we need to compute z-scores is to divide the difference of each value from the mean by the standard deviation. So a z-score is equal to this divided by this. And because we want this to stay put, we're going to fix 20 with $1. And I'm going to double click here so that I get all of the z-scores. What is the sum of all the z-scores? Well, let's go back here to think about this a little bit. These are the distances of all the measurements from the mean. You already know what the sum of all deviations is, because that's how we define the mean. You know that the sum of all these is 0. So their average is 0. So if we divide them all by the same number, the sum of all these will be 0 as well, and their average. And indeed, you can see it in Excel down here. Let us finally get to the real important information, which is the percentiles. So what is the percentile that corresponds to a z-value, a z-score of minus 0.83? Excel thankfully gives us a function to compute that, and it's called norm sdist. So that's the standard normal distribution. Open parenthesis. I want the percentile for this one. If you have set your PC to Norwegian, then you'll need a semicolon here. If your computer is set to English, you will need a comma here. To know which one you need to enter a second parameter, you should look here in the example. So when you type a function in Excel, Excel automatically pops up information about this function. And here it tells you that this function requires 2 parameters, a z-score and a value for the cumulative parameter that can be true or false. And the cumulative is the percentile, and the false, well, actually it's the proportion and the false is the probability density function, which you don't need. And you see in here, it displays a semicolon. If your Excel displays a comma here, just type a comma instead. So we want the cumulative here. So I double clicked on true, or I could have just typed TRUE, close parenthesis. And Excel doesn't care if you type capital or lowercase letters. I have been using uppercase letters here for the formulas because they look better as formulas. They look more like what Excel provides, but it makes no difference. You could have just typed norm as this with lowercase letters and Excel would do the same. So I'm going to press enter here. And why I got a 0 here is because the number is rounded. I have selected no decimal places. So you have to be careful about your formats in your Excel. Look up here. For some cells, it might say general. For others, it might say number or other things. And you should set this to what you actually have. Now we already had number, and this means that this column happens to have no decimal places selected. So you need to show decimals. I'm clicking on this one to add more decimals to the display. I could add more. I don't need those because we want percentiles, which is this times 100. So now we have 2 decimals here. See, all these are set to be, well, this was set to be number, and I could add more or have fewer decimal places. This one is set to be general. Excel decided to make it general because there's no decimal point. So these don't need to be numbers. If I were to set this to be a number, it would display decimal places, and I could not display them because they are integers in this case, and I don't need them. So you have to be careful to distinguish between what is the number and what you're looking at by checking your format. So let's make these into actual percentiles by multiplying by 100. And see, now this is general, and in order to remove the decimal places and use rounded percentiles, I had to choose a number and hide the decimal places. Double click so I can get the percentiles, and these are actually proportions, and they're cumulative proportions. So in this way, we have seen several important features of Excel. We have seen how to use formulas and functions, and we have computed z-scores and percentiles for a set of measurements. It is also very simple to compute scaled scores based on these z-scores. So to produce scaled scores, all we have to do is multiply the z-score by our desired standard deviation and add our desired mean. So I'm typing times 15 plus 100, enter, and I'm going to double click here to extend the range all the way down. Now, as you see, Excel has determined this to be a general format, but I want this to look like an integer, so I can turn it into a number and make the decimal places disappear. And I could very easily produce a different scaling, for example, a 10.3, by doing equals. Always have to go through the z-score. There is no other way to rescale because the z-score contains the information about the number of standard deviations. So multiply by the desired standard deviation, add the desired mean, turn this into a number, no decimals, and these are our scaled scores on a 10-3 scaling.